El Nino, La Nina, or La Nada. Now on Weathermedics Weather Buff. I am Jack Knack, the Weather Medic, the Doctor of Weather, with your October 2023 El Nino, La Nina, or La Nada forecast discussion. We're under an El Nino advisory. El Nino is anticipated to continue through the Northern Hemisphere spring with an 80% chance of El Nino still being around during March through May 2024. In September, equatorial sea surface temperatures were above average, though positive anomalies weakened in the eastern Pacific. So let's look at the sea surface temperature anomalies. The yellows are between 0 degrees and a half a degree Celsius above normal. The butterscotch, a half a degree Celsius to 1 degree Celsius, or 9/10 of a degree Fahrenheit to 1.8 degree Fahrenheit above normal. The orange are 1 degree Celsius to 2 degrees Celsius, or that's 1.8 degrees Fahrenheit to 3.6 degrees Fahrenheit above normal. The reds here are 2 to 3 degrees Celsius, which is 3.6 to 5.4 degrees Fahrenheit above normal. And the reds here are above 3 degrees Celsius, 5.4 degrees Fahrenheit above the normal. For a detailed explanation of the Nino regions, please see the link in the description or click the link at the end of this video. All of the latest weekly Nino index values remained in excess of 1 degree Celsius or 1.8 degree Fahrenheit above normal. Nino 4 was 1.2 degrees Celsius or 2.2 degrees Fahrenheit above normal. Nino 3.4 was 1.5 degrees Celsius or 2.7 degrees Fahrenheit above normal. Nino 3 was 1.9 degrees Celsius or 3.4 degrees Fahrenheit above normal. And Nino 1 plus 2 was 2.6 degrees Celsius or 4.7 degrees Fahrenheit above normal. Area average subsurface temperatures anomalies decreased, but remained above average, consistent with elevated subsurface temperatures across the central and eastern equatorial Pacific Ocean. One thing to notice here is that the depth, you're going down to 300 meters. Parts of the Pacific Ocean are up to 4 degrees Celsius above normal, and some areas right in here are 6 degrees Celsius above normal. So in Fahrenheit, that's like 10 degrees warmer than normal in the subsurface, about 50 meters depth. Tropical atmospheric anomalies were consistent with El Nino. In areas of the Central Pacific, low-level winds were anomalously westerly, while upper-level winds were anomalously easterly. Convection was enhanced around the international dateline, stretching into the eastern Pacific just north of the equator. Convection was suppressed near Indonesia. In Indonesia, there's more sunshine because there's less convection, and sea surface temperatures are a bit cooler, which is helping the outgoing long-wave radiation. The Equatorial Southern Oscillation Index and the traditional station-based Southern Oscillation Index were both significantly negative. The Equatorial Southern Oscillation Index is calculated as the standard anomaly of pressure difference between the area average monthly sea level pressure in an area of the eastern equatorial Pacific, that's between 80 degrees west and 130 degrees west, and between 5 degrees north and 5 degrees south of the equator, and an area over Indonesia from 90 degrees east to 140 degrees east, and once again, 5 degrees south or north of the equator. The Southern Oscillation Index is calculated as the standardized difference between standardized Tahiti monthly average sea surface pressure anomalies and standardized Darwin monthly average sea level pressure anomalies. The following diagram shows the difference from average sea level pressure during winters when the Southern Oscillation Index is strongly positive at the top or negative at the bottom. During La Nina, the positive Southern Oscillation Index, the pressure is higher than average red over the Central Pacific near Tahiti and lower than average gray over Australia. During El Nino, the Southern Oscillation Index is negative and the anomalies are reversed. As I said a few moments ago, the Southern Oscillation Index is significantly negative. So like all air pressure flows from an area of higher pressure to an area of lower pressure. So the air during the La Nina phase is going to flow from east to west. During the El Nino, which we have here, is the negative phase of the Southern Oscillation Index. You have higher pressure all over Australia, lower pressure over Tahiti. So you have high pressure, low pressure. The airflow is going to flow from higher pressure to lower pressure, which is why we have these westerly trade winds, because the pressure difference is so much greater between Darwin and Tahiti. Collectively, the coupled ocean atmospheric system reflected El Nino. Expect a strong El Nino event with a 75 to 85% chance through November through January, in which we're 1.5 degrees Celsius or 2.7 degrees Fahrenheit above normal for the seasonal average in the Nino 3.4 region. There is a 3 in 10 chance of a historically strong event that rivals the years 2015, 2016, and 1997, 1998, where the seasonal average was greater or equal to 2 degrees Celsius or 3.6 degrees Fahrenheit above normal. In summary, El Nino is anticipated to continue through the Northern Hemisphere spring, with an 80% chance of El Nino still being around in the March to May 2024 season. What would El Nino mean for a global climate? In general, the warmest year of any decade will be of an El Nino year, and the coolest a La Nina one. The next monthly video on the El Nino Southern Oscillation will come out on around November 9th, 2023. If you'd like to see more of these posts or would like to say thanks for this one, please consider becoming a supporter. To support the channel, go to patreon.com/WXMedic. This is Jack Kanak, the Weather Medic, the Doctor of Weather. Thanks for making Weather Buff a part of your day. Good day, everyone.
Weather Buff.